Welcome back. In earlier lecture, we understood some basic Docker commands. We understood how to actually start a container, how to stop it, etc. So now in this lecture, we'll quickly review about those basic commands, learn some extra commands, and also we will see how to create our own images. Okay. So quickly to go ahead, docker pull command is what we used to pull a image from docker repository. So if I want to list all the docker images will give this, or docker image ls, same, whether you fire a command docker images or docker image ls, both are same, you're getting same response, right? So there are two images. How do I delete these images? Docker RMI for removing an image. I don't want hello world. Hello dash world. So it is deleted. Now if I use Docker images, yeah, this is the one. Now if I want to see what all containers are running, Docker PS will give me, or Docker container ls, both are actually same. So Docker container ls, Docker ps, both are same, you'll get same result. So the new way of actually firing a command is Docker container ls. The old way is this one, Docker ps. Both are still supported. Now there are no commands running. Docker ps a will list all the stopped containers also, nothing running. Okay, now I will actually say docker run nginx. Nginx image is already downloaded and it will automatically start. Now from another terminal, if I say docker ps, it will show me the container id. If I want to remove it, I can use docker rm. If you want to forcibly remove it, see, if I say docker rm b8 d8, first four letters or first three letters also will be sufficient. Let us see what will happen. It is saying you cannot remove a running container. Because this container is running, you cannot remove it. So what you might want to do is, sometimes you want to forcibly remove it. Docker rm -f. So this will actually forcibly delete or stop a container and remove it also. Now if I say docker ps -a, the container is not even there, it is stopped, as well as the file system, everything is removed. So we also understood how to start a container by using docker start. Fine. And also how to actually enter into that container by using docker exec also we understood. Now let us start creating our own container. Now what I want to do is, I want to create my own container. So I'll tell you the process. First of all, this is my GitHub repository. I will clone it. Git clone. Okay. So I have some files here. I'll tell you how to actually create. Okay. So I'll cd into this Docker training folder. Okay. Now what I want is, I'll go inside this Ubuntu with ping IP. Okay, I'll cd into 01, this one. Let me tell you. Yes. So basically, I have files called as nginx dockerfile dash v1. So to create a image, what I want is, I want a nginx server. As you, if you know, nginx is a web server. So whenever I say docker run nginx, web server will start. But you might want to place some of your HTML files some of your static files inside this nginx server and then start it so that you can access these HTML files from your browser, right? So what I want is I want a nginx image which contains this nginx image, on top of it some HTML files. So I want to create an image on top of nginx existing image. So let us see how to do it. So if you want to create your own image on top of an existing image, we need to write a Docker file which contains some Docker instructions which tell how to create an image. So let me show you how a sample Docker file looks like. So I just use vi nginx. I wrote a file with some name. Okay, I'm opening it. See, the first line is from nginx. So what you want to do is you want your image to be on top of existing nginx image which can be downloaded from Docker Hub. So this command, what it will do is it will check in the local repository. Is there nginx image already? If no, it will automatically download the nginx image. Then on top of that, it will run the next command. The next command is I am executing apt get update and apt install, all this. So on that nginx image, whatever commands I execute, I specified, they will be run. Run is a command name, Docker specific command name. Then what I want is I want to copy the local files onto the nginx machine. So let me show you. I'll just cd here into Docker training. I'll cd into the same directory. Okay. If you see the files, I have a folder called as static files v1, ls static files v1. There is hello.html. I just cat this static files v1 slash hello.html. It is just specifying, right? I have written only hello from v1. That's all. Okay. I want this HTML file to be copied onto the nginx file system. Normally, nginx looks for HTML files under this standard path /usr /share /nginx /html. So I want to put my current HTML folder, which is present inside static files v1, into this one. So copy is a command which will copy the local files onto the image. So these are the three simple commands which I have written in a Docker file. Then using this Docker file, I want to create an image. How? Let me show you. Very simple. To create an image, to build an image, the command is Docker build. I want to build an image. And once the image is built, I want to tag it with some name -t, and I'll give a name for my server. I'll give my nginx. This is the tag which I'm giving to my image. Then uh, which folder contains the files using which you want to build the current one. And then I'll give the file name nginx. Sorry, I have to use a command -f. The file which contains my Docker instructions is -f nginx docker v1. Okay. So what this will do is I am firing this command on the CLI, right? CLI will make a REST API call, and a REST API implementation will talk to the Docker engine, and we are getting the output. See here what is happening. Uh, First, it will check if the local file is there. Then it is executing this command. The files are downloaded, and then the copy command is executed. Okay, so it is writing the image. Now if I execute docker images, I can see my nginx, right? Which is built on top of existing nginx. I'll tell you clearly what has happened, but now I want to start my nginx. What I can do, simply I can write docker run my nginx. Very simple. As usual, it will start nginx, right? So what has happened, actually, um, when I actually built a image using this file. This is my nginx docker v1 file. I have created an image using this file, right? Let me tell you what all happened once I built. So what is the command I used? Let me show you. Assume that this is a machine on which Docker engine is installed. Here there will be Docker daemon running and REST API. Assume that from another machine I have fired a command. This is my client machine in which I have CLI. Assume that. Here I have my application related files. What on this machine? Sorry, on this machine I had I had all the files, nginx v1, all the static files, whatever I want, all this. So once I fired a command, what is the command I did? Docker build and tag it with the name. I gave my nginx and I gave the current folder as a build context. Whatever is coming after dot means current folder is a build context. Then hyphen f, my file name. What is the file name I gave? It is nginx docker v1. Whatever name I gave. Okay. So once this command is executed, what will happen? The CLI will make a REST API call and it will send all the contents of this build context. All the contents of this folder, current folder, will be sent to API, and the client will ask the REST API to build an image. This will talk to Docker daemon and ask it to build an image. What this Docker daemon will do is it will execute the instructions one by one. So what it will do is the Docker daemon, first it will launch a namespace, process namespace, pid namespace, mount namespace, and start a process inside it, a batch process. Then inside this batch process, it will, of course, a file system also will be present for this container, right? So it will execute the contents of my Docker file. So first command is what? From nginx. So what it will do? It will download and download the nginx related files. Okay, and then the next command will be executed, sudo apt. The output of that also will be added. Then the copied files also will be added. Now this container is having a state, right? The state of this container will be saved and it will be tagged with the name my nginx. This is nothing but the image. The image is stored locally now on this particular machine. The image is stored locally on this machine. So the image got created. Okay, this is a high level overview. But now, as we know, overlay file systems, actually Docker will use overlay file system for actually creating the images and all. I will tell you how the image contains image is using overlay file system. Okay, so let me just tell you here. I'll log into here. So Docker images, it will list my nginx. First of all, Docker ps. Let me terminate it. Docker rm-f. It is starting with 0 to b. Okay, let it be removed. Let it be very clear. Now Docker ps, nothing. Docker ps-a, nothing. Now Docker images, it will list all the images. Now I will execute a command docker inspect my nginx. Oh, when I said inspect, it has given me a big output. Let me maximize it and again execute it. Yes. Now let us see the output of inspecting. Here, if I go down, it contains all the information about this particular image. If I go down, here you can see in the data of this image, you can see lower dir, merged dir, upper dir, work dir, etc. Right? So let us see the lower dir. In lower dir, it is comprised of multiple folders. This is one folder, and this is another folder. This is another folder. So lower dir is comprised of multiple folders. So what I will do is right now, I will actually go into first folder and check the topmost folder here, ls. Let us see what is there. Oh, sudo. I'll do sudo. Okay, there are some files in this. Okay, then I'll take next one. Again, sudo ls. Oh, see something called as docker entry point.d. Okay, then let me actually take the last folder here, ls. Okay, again I have to sudo, otherwise I'm getting permission denied. So it looks like some root file system, is it? It looks like Alpine file system. Yeah, it's looking like Alpine file system. Fine. You understand clearly that um, that Docker is internal using overlay file system, and this is a merged dir. Once I launch a container, once I launch the container, this will be the merged directory where a container will see all its files, right? So basically, what is happening is, um, let me copy this command. Okay, these are the commands. Fine. So now, when first command is executed, um, it'll the image is downloaded. This will be the upper directory. Then this image will be saved. Okay, this file system, whatever files are there, will be saved. Then when next command is executed, this upper directory will become the lower directory, and then the output of the correct command will be inside the upper directory, and this entire state will also be saved as one more image. So I will say this as image 1, just I'm naming it. This is one more layer, image 2. Then when third command is executed, now what happens? This entire image 2 will become the lower layer. This is image 2 now. And um, this copied files hello.html will become the upper upper directory, right? And this entire will be saved. So how many images? Three images will be saved, right? So actually they are layered. Now whenever we start a container using this image, what will happen? These all layers will become the lower dir. Lower dir will contain the hello.html and the previous image, and upper directory will be empty. Merge directory also will contain the combination of lower directory and upper directory. So like that, Docker uses a layered file system. So basically Docker is also using overlays, and after running every command from the Docker file, one layer is created, and this layer also is saved. Now, if I just run a command docker history my nginx, wow, um, yep, it is showing some files like actually how many layers. These are various layers. This is the latest layer where I copied HTMLs, right? The other layers, okay, this is the latest layer, topmost layer. This is the below layer where I executed sudo apt get update and all, right? This is the next layer, the top layer. This is the top layer. This is the below layer, right? The image ID will not be there, but the images are stored. So actually, for every command, whatever is executed, the layers are written, and this is the top layer. So basically, my nginx image is a combination of all these layers. So we say that Docker follows layered architecture. The file system is a layered file system. For every command in Docker file, a layer is created, right? That is how image is created, and you understood how to create a basic Docker file. So I don't want to actually go on to multiple commands in Docker. It is very simple. What you can do is you can just Google for Docker file commands. This will actually take you to the Docker documentation where you can see various commands. If you want to run a command, run. I used already run to run a particular this one. I used run. From if you want to extend your image from existing image, from if you want to run a command, then this is a one, and copy, this is a command, right? So uh, once the container starts, what should be the command that should be executed? You can specify that by using cmd. So everything is listed in this Docker file. Reference, run command, how to use run commands, various things all are given here. Anyway, most of the times as a developer, um, you will be building building high level images from an existing image. Mostly these commands will be sufficient for you, right? Here in this course I don't want to actually talk about all the commands. It's all about knowledge, right? We're focusing only on the concepts. So we have understood what happens when image is created and how Docker is actually using layered file system or overlay file. Let me also show you by inspecting the running container. So what I'll do is right now Docker PS, is there anything running now? So Docker run my nginx is the image name, but I want it to run in foreground. I can use a command -d to run it as a daemon. So I'll get the terminal back immediately. and this is the container ID, a bigger container ID. So Docker PS, now I have executed nginx in the backend. This is the Docker container ID. Fine. Now I want to inspect the running container. Docker inspect uh, container 879. Okay. So this is giving the total information about this particular container. Now you can see some information. Yeah, this is the lower directory. This is the merged directory. Let me just list the merged directory. Oh, first of all, let me say df-a. Okay, here you can see that there is a mount point created merged. This is the merged directory. Copy and let me cd into it. Sudo, by using sudo cd. Okay, okay, cd not found. Can directly cd without sudo. Okay, permission denied. Okay, anyway, I think it's a permission issue. Even if I do sudo also, yeah, I'm not able to look into it from the root file system, but this is the overlay, right? This is the merged directory. Is it the same thing ending with 7f4 slash merged? Ending with 7f4 slash merged. This is a mount point, right? So using this upper directory and lower directory, merged directory is created, right? So let me actually go into this upper directory at least. Let's see what is that. ls, sudo ls. Yep, it contains some folders, right? This is upper directory. So here I want you to understand. So actually, whenever you are creating any image, layers are created. What is the advantage of layering these images? Suppose if you create one more image from my nginx, from my nginx, what will happen? The content of my nginx will become the lower directory. Upper directory will be empty, right? Upper directory is a copy on write. Whenever we modify any files in the lower directory, they'll get copied into upper directory. Remember, copy on write concept. Yes. So basically, whenever you are building images which contains same instructions, suppose if you are actually building uh, one more image using first two instructions common, but third instruction will be different. What will happen? It will check. Okay, for this instruction already there is a layer. For the next instruction also there is one more layer. So it will not create one more layer. It will reuse the existing layer. Anyway, whenever it is reusing an existing layer and building on top of it, these layers are going into lower directory, right? So even if this lower directory is a read-only directory, if you modify any files in the read-only layer, a copy will be created in the upper layer. No issues. So if you create one more image using same instructions, same first two instructions, this layer will not be again created. It will be reused. Let us see. Actually, I have one more thing. Mm, In the same directory, I have nginx docker v1. Let me actually cat it, v2. See, the first two commands are same. Only the third command is actually copying from another folder. Only third command is different, right? So if I create another image, docker build, I want to build another image and tag it with another name, my nginx2. I'm creating another image dot, the current folder is a build context dot f nginx v2. See what is happening. The commands were executed very fastly. You can see it got from the cache. First from nginx is executed. It didn't build it again. It is getting it from the cache. See, this layer is cached. This layer is cached. And only third command is executed, right? Anyway, this nginx is already there. Nginx image is already there. So it didn't download. Second command also is not executed. A new layer is not created. So it is reusing the existing cached layer. Then third command is executed. Like that, by using overlay file system or layered file system, the layers are reused across images. So that's about how to create your own image. In the next lecture, we'll see a few more commands related to Docker. See you next lecture.